I've been having this discussion with my algebra students, my college algebra students, and I want to make sure I have it with you because I think it's important to realize this. Every class, regardless of the course material that we're going through, so college algebra, algebra 1, geometry, trig, calc, even all your science classes, even in all your English classes, can you read every single book that was ever written? No, right? That's impossible, right? You're not going to be able to do that, okay? However, you are given the tools, you learn the tools, the skills to be able to read any book that you ever want to read, right? So math is the same idea. We're not going to be able to see every single example problem ever created, okay? And we could do 15 minutes, 180 days, all year long of just practice problems, just examples. And what that will turn out to be in the long run is a very, 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 very small percentage of the possible questions that you could see. Because there's an infinite number of questions, right? My hopes are that the way that we teach this, that we go through this, is that we provide you with the tools and the understanding and basically the logical processes that allow you to see any type of problem and address any type of problem and be able to change and adapt to that. Okay? So that's why I spend a lot of time talking about the properties, a lot of time talking about the theorems and then the relationships and that kind of stuff, and the procedural processes of going through questions and how to kind of analyze a question. Today we'll talk about how we can kind of maybe start removing parts of the picture to see if anything kind of jumps off the page at us. If we can learn those things, that allows you to have the skill set to maybe address any type of question we come across. Does that make sense? Okay. My algebra students are arguing, well, you only do one or two examples. Okay. Well, I want you to learn the math. I don't want you to be able to do what I do and just be able to copy the type of problem that we're working on. Because when that problem changes just a little bit, do you have the skill set to adjust to that? Okay. And that's kind of how we kind of frame mathematics. Okay. So from here on out, whether you have me or anybody else that teaches the math in high school, it's going to be that way. Okay. So this one here, they start asking you to find values for x and y. Okay. Did we talk about last week that those arrows, the red arrows, tell us something about those lines? Okay. Tell us that those lines are parallel. Good. Okay. Now, as I look at those red lines, so I know I'm going to have to use those. I know that line right there and that line right there, if they were not useful to me, they probably wouldn't tell me that they're parallel. Does that make sense? Okay. Now, when I look at those, that gives me two other lines that cross those. So those two other lines are both transversals. Okay. But I want to look at one of them and one of them only. Okay. So what I'm going to try to do here is eliminate this transversal. So if I get rid of that transversal, does it ultimately get rid of that angle there that's made that they're calling x? And if I keep erasing this transversal, it really gets rid of y. So that angle has now disappeared. Come down here and get rid of this transversal down here as part of it, and that will wipe away that 4y. And I'm left with that. Okay? So what this tells me right now is that I've got that angle there and that angle there, and they're alternate interior. Would you guys agree with that? So they're equal, but does it give me any way to set them up and create an equation? I don't have expression for those things, right? So even though they are congruent, they're alternate interior angles, they are congruent, what I'm finding out here is that by looking at that transversal, it doesn't lead me anywhere. It doesn't lead me anywhere useful with the mathematics, okay? So by erasing that transversal, I didn't find anything useful. So what do I do then? Erase the other transversal. If I erase this one, that does not get rid of any of those expressions, x, y, or 4y, because by erasing that one, I didn't eliminate any of those angles that are being displayed using x, y, or 4y. Okay? So now does that generate kind of that fundamental parallel line transversal picture that we define all of our properties off of? And my hopes are now that we can develop some relationships. Now, I'm going to go maybe a little bit further with this, or maybe approach it in a different manner than what most of you probably did. Most of you right away probably picked off the relationship that you need to do or needed to use here to solve for probably y right away, and then use that to solve for x. I'm probably going to make that argument, okay? But again, I want to teach you processes, okay? I want to teach you the process so that when maybe we're talking about triangles and maybe interior and exterior angles of triangles, that what we learn here procedurally, you could transfer over to what we do there. And then we start talking about parallelograms and maybe rhombuses, and maybe down the road when we talk about similarity with sine, cosine, tangent. You can take the principles that we learned here and transfer them over to new types of problems. Okay? And here's my argument. You know there's a lot of relationships existing here. Is there a relationship between that blue angle and that blue angle? What's the relationship between them? They're a linear pair. Good. Okay, so if they're a linear pair, they have to be supplementary. So I'm going to write that down. I'm going to write x plus y equals 180. Okay? And this is the game that we play. A lot of times maybe that the equation that jumps off the page right away at first is the one that we can solve. Okay? This one I write down. I know it's a true fact, but can I solve this numerically for x or y? Okay, so I can solve for y and get like, what, 180 minus x, right? Or I can solve for x and get 180 minus y. But I can't get y, what it is numerically, unless I know what x is, right? Or vice versa. I can't solve for x unless I know what y is. Okay, so that equation is true, but it doesn't get me anywhere in solving for x or y. So then I look at another relationship, and maybe I look at those two angles. What can you tell me about those two angles? Based on their position to one another, the x and the 4y, they are what to one another? Say again? Close. Starts with a C, O, corresponding. Okay? So these are corresponding. Corresponding angles are, what's the relationship between them? They're equal. So could I say x equals 4y? Does that make sense? So that's a true statement. Now, here's the thing. That is actually, with those two equations, this is enough to solve this problem. But there's something better yet. What's x? Okay. How'd you do that?
I did 4y plus y equals 5y equals 180.
Okay, so using these two equations, did you say, okay, if this is x equals 4y, replace that with 4y? Okay, and that's fine. That's my argument, is that with these two equations, you can absolutely use substitution and elimination. My thought is, I'm going to try, before I even turn to elimination or substitution, I'm going to make sure that I kind of utilize all the relationships that are there in the picture. And what are those two angles? As a group, are they interior or exterior? Interior, and are they on alternate or same side? So same side. So these are same side interior. So what are you going to say the relationship between those is? Same side, supplementary, right? So my hopes are, guys, is that there's 20 people yelling, because that's an easy answer. 20 people saying they're supplementary. Okay? So now that is an easy equation to solve, right? And that's exactly what Skylar ended up with by using substitution here. Okay? But as you progress through the year, if there are situations, if there are equations and relationships that exist inside your problem that allow you to have an equation with one variable, you're going to want to utilize that, because that's always easier to solve than an equation with two variables. Okay? But nonetheless, either way, you're going to get 5y equals 180. So y then would be 36. Okay? So if y is 36, And here's the thing. And this is the purpose that I did this. As we wrote these equations down up here, that equation I did not use yet. That equation I did not use. And if there are equations that are true, but you can't use them yet, do not erase them. Okay? Because once I know what y is, can I go back up into either of those and plug in and solve for x? Does that make sense? Where if I wrote down x plus y equals 180 and say, that doesn't get me anywhere, erase it. Write down x equals 4y, that doesn't get me anywhere, erase it. And then I get 4y plus y equals 180, y equals 36. Then what do I have to do to find x? I have to generate one of those equations that I erased, right? I'd be doing the work that I've already done. So when you get a relationship that you know is absolutely true and it generates an equation, keep that equation. Whether you use it right away or not, eventually you're probably going to come back to it and use it. So then if y is 36, plug it in here or there, x, like Skylar told us, will be 144. Okay? And you should be able to go in your picture and say, okay, well, x and y had to be a linear pair, so 144 plus 36 does give me 180. And all those relationships that we know should exist do exist with those values. Okay, so the grand scheme of things, the overall procedure, guys, trying to teach you is that there may be times where they provide, and I say may, there will be, and it's going to pretty much happen every single problem we see. They're going to add visual clutter. They're going to give you things that aren't there to help you. They're there to distract your attention from what you're trying to focus on. Okay, and if that's becoming an issue for you, how do you approach that? Okay, start redrawing pictures. And I know it's easy for me because I'm using the computer and I can cover things up and all that kind of stuff. Not so easy for you guys on paper. You might have to redraw. You might have to take the image that they start you with and redraw it 2, 3, 4 times before something jumps off the page for you to develop a relationship. Okay. Here, my starting point, guys, when I'm doing this, because there are times where I'll look at a picture and I'll start covering things up, and I cover up the complete incorrect stuff. For instance, here, what if I start eliminating that transversal? If I eliminate that transversal, don't I eliminate the angle that was made by that transversal? And if I eliminate that stuff, I'm left with parallel lines and a transversal, but there's nothing I can do there now, right? Okay? So it's always good to, obviously I know that angle there and that angle there have algebraic expressions. So you probably don't want to erase the things that make those angles. Okay, well I know this transversal has nothing to do with making those angles. Okay? So get rid of that one. And then again, if we were to extend that, and extend that, and extend that, we get back to that fundamental parallel lines cut by transversal. Now those blue angles would be what based on their names or their vocabulary word? Corresponding, okay? Another thing, guys, we should hear 20 people yelling corresponding angles. Okay? And then 4x minus 11 should equal x plus 46. Corresponding angles have to be congruent, right? And we just go through that algebra and solve for x. Special type of parallel lines and transversal. Okay. Again, what kind of angles then? These are parallel lines. What kind of angle is that and that in terms of their location to one another? In terms of are they same side interiors, alternate interior, alternate exterior, or corresponding? What are they? Corresponding. Good. Okay, so we're going to say that corresponding angles are congruent. So what is the number that they're putting there? Okay, so they're saying 90 degrees there. So we should say 4p minus 14 equals 90. Now, that is actually a relationship that is going to be very useful for us. Okay? Because what we find out then when we find p and plug that back in, this angle's got to be 90 as well, right? Okay, they got to be same side interior, corresponding, so they got to be the same. Here's the idea. If I have two parallel lines and my transversal is perpendicular to one of them, would you guys agree that my transversal is perpendicular to that bottom parallel line? And doesn't it have to be perpendicular to both of them? Does that make sense, everybody? Okay, so think about look above you, okay, or maybe look at the grid on the floor below you, okay, with the tiles, okay. If I want a bunch of right angles in these tiles on the ceiling, right? Does that make sense? Everybody look up. See the tiles on the ceiling, right? You see the grid on the ceiling, right? Okay. Now, whoever put those in did not go and make every one of those rectangles a rectangle with measuring every angle inside those as a right angle. What they did is that they guaranteed themselves that they would get perpendicular lines as long as they took these east to west lines, that are going from the front of the room to the back of the room, and they made sure that they were parallel. Does that make sense? So they made sure the distance between them was the same. And then whenever I make a right angle here, then move it over here, make a right angle right above me, then that means when that line right there is a transversal to all the other ones, it's going to be perpendicular to all the other ones. Does that make sense? And that's a very quick way to generate all those rectangles so that those tiles that you go and buy that are all the same cut will fall into those rectangles perfectly. Okay? But that's a great, useful tool. And we'll see this as a theorem in, I think, maybe not the next section, but the following section, that when you have parallel lines and a transversal is perpendicular to one of them, it's perpendicular to both of them. Okay. This question, then, this one was the one that was missed the most of the people that have started the assignment. This one was either attempted the most or ultimately missed the most. And there's a lot of different ways of doing this, guys. A lot of different ways. Okay. I want to do it in the fashion of just maybe highlighting. I know I've got two sets of parallel lines. I'm just going to look at one set of parallel lines. I'm going to look at one set. Maybe I look at those two, and then I look at a transversal. So which transversal do you guys want to look at? Skylar, you're going to tell me something. What are you going to tell me?
I did this question really easy.
What, when you say vertical angles, though, you're telling me, like, the only vertical angles I see here are those two and those two. I think you're thinking, okay. So you want to look at that transversal there. And what you're saying then, for those of you that maybe struggle with this question, if I'm looking at those parallel lines and that transversal, all of these things kind of vanish. They're not associated with that set of parallel lines and that particular transversal. And what am I left with? What kind of angles are those? Because they're on the inside. Are they on the inside of my parallel lines? Okay. And they're on the opposite sides of the transversal, right? So they're alternate interior. And you're right that the conclusion of it is that they are the same. So V.
That's how I did. I did all of them, and I added them up.
Good. So V is equal to 41. Okay. And here's the thing, guys, is that right now, a lot of you, I think, are seeing a relationship. V's got to be 41 or something like that. But are we able to communicate that? Are we able to use the appropriate terminology for us to be able to communicate our ideas? Because if we're not, the end of course exam, which will judge whether you get a graduate or not, will target that. Okay, and it'll make sure that you're able to communicate effectively within these concepts. So we need to know that vocabulary. Okay, so that's great. Then we need to look at other parallel lines. I don't know why. Sometimes this thing doesn't let me click on the markers I want to use. All right, so now if I want to click on maybe that parallel line and that parallel line, a couple different transversals I could use. Can I look at that transversal? Does this break down to give me a similar relationship? If I remove enough, what can I see that W is going to be the same as? W is 20 degrees, right? Okay. Try it again. Maybe I focus on maybe this parallel line again. That one, I've already used this transversal. Let's try that transversal. If you think about that, this one's not really going to get me anywhere. Because what I'm left with then is y equals y, right? Is that true? Does y equal y? Absolutely, all the time. That's called an identity, but it doesn't get me anything here. So even though it's true, it doesn't get me anything. Eventually, I think you're going to have to get down to the point where maybe you look at maybe that, and that. So I got these two parallel lines, and now that transversal up top. And what I'm going to do is erase this stuff. Okay, now I don't want to erase all of this up here because I want us to realize that that angle there and that angle there, would you guys agree that they make that angle? 41 and W make that angle, right? So what would be an expression for this angle here? That's 41. I'm going to add W to it. How do I get that red angle? What would be an expression for that red angle? 41 plus W. Does that make sense, everybody? Okay. We've got the angle addition occurring here to get that red angle. How do I get that angle? 88 plus Y or Y plus 88, right? Now, what can you do with those two angles? Because you know that this line here and that line there are parallel. These two red angles are what to one another? If we look at our parallel lines extended, they're supplementary, right? They're same side interior angles. So add them together, send them equal to 180. And that's what you were saying, Skylar, that you did, right? So now I've got V, I've got W. Okay, well, if I plug in W right here, I get 41 plus 20 plus Y plus 88 equals 180. Subtract all those from 180. And I believe that gives you Y equals 30. Is it 31? Move that over, gives me 92. 92 minus 61 will be 31. So Y is 31, right? Okay. I'm still missing X, right? So still missing X. Can I do the same thing down here? Or can I do, maybe look at those two. Maybe it's easier to look at those two and say, okay, if I look at those two parallel lines and that transversal, X has got to be what? X has got to be 88. But, like I said, that's not the only way you can do it. If I look at these, could I say X plus Y plus 20 plus V equals 180? That angle there and that angle there, same side interior. I know what Y is. It was the 31, so X plus 31 plus 20 plus V, we said was 41, equals 180. If I go ahead and plug that in, subtract that stuff away, I should get the same value for X of, 88. Does this kind of make sense? Okay. That's the thing about geometry, and that kind of reaffirms what I said at the beginning. I want to teach you relationships. I want to teach you how you can do an infinite number of problems by knowing what your properties are, because looking at this one, there might be, 10, 15, 20 different ways that people logically argue what X, Y, W, and V are, and all be correct. Okay? So I don't want to say, oh, this is the one, you're going to watch me do this problem, this is the one way we're going to do it. Because I don't think that's right. Okay? All right, so finish that up. Make sure that you complete that assignment before this evening. And I want to do one more proof with you. So I'll give you a minute to write this given and prove in that picture down. My plan is, so as you're writing that down, can I talk to you? My plan is Next Thursday will be our last day of the 9 weeks. Friday is actually the last day, but you guys don't have school Friday. So I am going to we'll have a test by the end of next week. Okay. Now, my hopes are that we get through all of Chapter 3 by then. Okay. If not, we'll lop it off wherever we're at. We'll have a test, and then we'll pick up with Chapter 3 after the 9 weeks. Okay. I'd like to, at the end of 9 weeks, give one more large assessment for those people that are on the bubble, okay, to firmly place yourself on the correct side of the bubble. Okay, does that make sense? All right. So that being said, there will be an optional review, an additional one of those that pops up, so there's more points there we can gain, and then likewise the potential to do well on that test. Okay. I don't think so. Why? Which Monday? I don't think so. I wish. Huh? All right, guys. What this question, the way I've got this set up, or the way I used to have this set up, if I can move these things out that I just did, was something like this, where, and this is kind of one of the structures that you'll see on the end-of-course exam if they ask you to do a proof. Usually there's about 3 to 4 proofs on there, or 3 to 4 types of proofs on there. Some of them you're filling in statements and reasons and writing them out, okay, typing them out. Some of them are drop-down windows like we've already seen. Another version is they might give you like the entire proof, but they leave one line open, and you got to put in the right thing in that one line. The final version is something like this, where they give you down at the bottom, they'll give you these block statements, and it's a grouping of statements and reasons, and you have to be able to take your cursor and click on one and move it into the right position in its statements, and then provide the correct reason on the right hand side. Does that make sense? So you'd be clicking those and dragging them and matching them up correctly in the right order. My philosophy is that if we can do this without having any guidance, because I think when they give you those statements down the bottom, they're giving you some type of guidance. Does that make sense? It's narrowing your focus on the statements and reasons you've got to use. My thought is if we can do this without any of those and just use our collective understanding of geometry so far, then on the end-of-course exam, it should be a much easier process when they narrow your focus. Okay? So as we do proofs throughout the year, that's my philosophy. Can we do a proof when we get to chapter 13? Can we do a proof that we are using 13 weeks or 13 chapters worth of cataloged information, so that when we get on the end-of-course exam and they give me a proof that is similar to what we do in chapter 13, but they narrow my focus to sections 13.1 and 13.2, it should be very easy for me to do that proof then in that end-of-course exam. So my idea is always prepare for the hardest, prepare in a manner that will make you work the hardest, so that when the actual assessment comes, the actual testing comes, and it's easier, you've out-prepared yourself. You're over-prepared yourself, okay? And it'll be a breeze to perform on that assessment. All right, so, and statement number 1 here, we are given. So A is parallel to B. That's our given. Okay. Now, parallel is a vocabulary word. Okay. But it doesn't give us anything based off its definition ever. Okay. The only thing that parallel gives us are those four arguments that corresponding angles are congruent, alternate interior angles congruent, alternate exterior angles congruent, and same side interior angles supplementary. Okay? So, in the event of trying to prove angles 1 and 8 supplementary to one another, once I see the word parallel here, maybe I want to start using some of those things. Okay? So, what could you tell me? Just choose some angles over there. Tell me some relationships about angles that you might know over here. 8 and 5 are supplementary. Okay, so 8, so I'll say angle 8 and angle 5 are supplementary. Why? Well, that's what supplementary means. They're a linear pair. Okay, so once I write 8 and 5 are supplementary, maybe it's then that I say that they have to 180, right? But while I'm at it, and this might be useful or not, but you said 8 and 5. Are there other angles up there that I know a similar relationship with? Do I do?
5 and 7 are vertical angles. 1 and 8 are horizontal.
Okay, I agree with 5 and 7 being vertical. 1 and 8 are not corresponding.
Oh.
1 would correspond to 5. But let's go off of what we've already said was supplementary. Are there other supplementary angles up there? 8 and 7. So let's say angle 8 and angle 7 are supplementary angles. Still in your pair, right? Still the same region. Okay. Now, here's the thing, is that this might be something that is useful to us. We've seen something like this, right? We've seen in the past where we have two statements that say angles are supplementary, and then we go through a process, right? If 8 and 5 are supplementary, what can you tell me? They have to 180. So measure of angle 8 plus measure of angle 5 equals 180. And that's your definition of supplementary angles, right? When we make the statement that something is supplementary, we're using a vocabulary word, so then the conclusion of that vocabulary word is what we wrote here. So our reason will be the definition of that vocabulary word. So if I can say that, I should be able to say measure of angle 8 plus the measure of angle 7 equals 180. Right? Still definition of supplementary angles. So let's put all that underneath statement 3. Is this similar to something we've seen in the past? Have we in the past seen those two things being both 180? And then we can link those two things. So measure of angle 8 plus measure of angle 5 equals measure of angle 8 plus measure of angle 7. In the past, we called that substitution. And whenever that happens, generally there's something that will show up on both sides that is the same amount. What's the same amount that's on both sides here? Measure of angle 8. So let's wipe that away. I get measure of angle 5 equals measure of angle 7. So subtraction. Okay, statement 6 is going to say angle 5 is congruent to angle 7. That's the definition of congruency. Okay. And at this stage, I've seen some people kind of look around like, why are we doing this? Because we just got angle 5 be congruent to angle 7, right? And our logic is 100% accurate. But if you remember what we just did, this here, all of this, and I don't know if I can, highlight it all. That there, down to there, if we go back to our other theorems, and we look at our vertical angles theorem, that is the proof of our vertical angles theorem. Well, our vertical angles theorem was a theorem. We're allowed to use that. We know that's true. So could I have written all of that stuff right there simply as one statement that said angle 5 is congruent to angle 7, and my reason was because of the vertical angles theorem? Does that make sense, everybody? So everything in green there, it's nothing wrong with it, okay? But we've got a more concise way of writing it. Instead of writing it as 5 steps, we can condense it down to one step. Angle 5 is congruent to angle 7 because they're vertical, okay? That's the idea of why we have theorems. Instead of making this proof maybe, 10, 15 steps, our theorems will condense sections, okay, and allow us to make an argument much quicker. Okay? So, regardless of the route we go, we eventually get angle 5 congruent to angle 7. Okay? Look back up at my picture. What else do we know? We said something about 1 and 5, didn't we? Earlier, but we didn't write it down yet. 1 and 5 are what kind of angles? Corresponding. So step 7, we'll say angle 1 is congruent to angle 5 because corresponding angles are congruent. Now, when I write these statements, guys, I should be saying if two parallel lines are cut by a transversal, then corresponding angles are congruent. When I was in high school, my teacher made me do that, and I hated him for that. Okay? So I'm not going to make you do that, but I want you to understand that there's more to that statement, because when I say corresponding angles are congruent, that's only if the lines are parallel. There are corresponding angles that might not be congruent if your lines are not parallel. Okay? So now, let's do this. If I've got, because I've already said some things up here that are useful. We remember our overall goal is to get 8 and 1 to be supplementary. Right here it says 8 and 7 are supplementary, right? Is there anything that we know about angle 7? If we look down here, 5 is the same as 7. 1 is the same as 5, right? If I rewrite these, and this is what Riley's saying. If we go angle 7 is congruent to angle 5. Just flip this around. Then flip this one around. Angle 5 is congruent to angle 1. Careful. Just look at these two statements right there. Nothing else. 7 is the same as 5, but 5 is the same as 7. One of these is 1. It's supposed to be a 1. This one's a 1. Sorry, this is a 1. Wrote it kind of like I write my 7s. That's a 1. So 7 is congruent to 5, but 5 is congruent to 1. What does that tell me I can say about 7 and 1? They are congruent. So angle 7 is congruent to angle 1. If I look at them, I could use that fact. My logic here, I think, is the transitive property. But if you wanted to use alternate exterior angles, that's fine. I'm going to just say transitive here. And here's the idea, and whether maybe, I think the way I've designed this proof and where I put it in the PowerPoint is that we haven't talked about exterior angles being congruent yet. But if you want to write there that 7 and 1 are congruent because of alternate exterior angles, by all means, that's fine. It's right. Okay? And that's the thing about these. I don't want to show you just one way of doing it, because there's not just one way of doing it. Okay? So now, 7 and 1 are congruent. Come back up to this. 7 and 1 are congruent. Can I rewrite that statement and take out the 7 and put 1 in there? So now 9 will say that angle 8 and angle 1 are supplementary. And that's substitution. Now I know this proof is messy looking. Okay? It's messy the way we've done it. But everything in that green can be replaced by one phrase, right? Everything in green can be rewritten as angle 5 is congruent to angle 7. Do this on the white. You guys don't have to write this down. but I want to make a connection to what we talked about the first day we did proofs. So we said A was parallel to B, that was given. All this stuff in the green could have been rewritten as angle 5 congruent to angle 7 because of vertical angles. Okay? Down here, okay, now going off of what we said with the transfer property, maybe I put these two statements there, or maybe I go off of what Skylar said and said, well, angle 7 is the same as angle 1, okay, because of alternate exterior angles. Okay? That allows me then at step 4 maybe to say that, well, because of my picture, I know 8 and 7, angle 8 and angle 7 are supplementary angles, okay? And maybe I don't even need this statement using what Skylar said, because now look at these, 7 is the same as 1, so can't I just make that substitution right there? And say angle 8 and angle 1 are supplementary due to substitution. So really there's two, take that out or leave it, okay? Or that phrase right there. So there's really 3 different versions of this proof that we've just done here. Well, let's wipe that one away. We can either do the proof 9 steps, which is fine, or we can do the proof in 4 steps. Which one would you guys prefer to do? The 1 and 4. But do you understand that the 1 and 4, you have to have an understanding of properties and other theorems to be able to do that effectively? Okay? That's the idea, okay? Remember the first day we talked about proofs, I made an analogy to writing a paper in English class, right? First thing you do is write an outline, then you write a rough draft, and then you finalize that, right? And turn in a final product. This here on the smartboard, rough draft, outline type thing, okay? It got all my information kind of organized, and then I started making little amendments to it, little adjustments, okay? Figuring out what was useful, what was not useful, okay? Maybe different ways I could say some statements together. And then on the whiteboard up there, that's my final draft. That's what I submit. Does that make sense? Okay? Now, when I have you do stuff, because I will at some point have you do some proofs by hand, I don't care which one you give me. You want to give me the one on the right with 9 steps? That's fine. You want to give me the one on the left with 4? That's even better. Okay? But they both get me an argument that says that angle 1 and angle 8 are supplementary. Okay? So now, what kind of angles would be 1 and 8? Look at their position to one another. They're same side exterior angles, right? Same side exterior angles. If they're same side exterior angles, we just showed that they're always supplementary, right? If you have 2 parallel lines, then same side exterior angles are supplementary. So why is that not a theorem? Why is that not one of those statements that we said on Friday? Anybody know why? Theorems kind of earn that title of being a theorem based on their usage beyond the point that we define them, or the point that we recognize their property. Okay? So beyond 3.2 and 3.1, alternate interior angles show up all the time. Okay? Corresponding angles show up all the time. Same side interior angles show up all the time. Same side exterior angles, they're not very prevalent. They're a rare occurrence in the problems that we do. Does that make sense? So they don't warrant, because of the usage of them, they don't warrant a theorem to be used with them. Okay? But if we want to make our own little theorem, there it is. Okay? It's a fact that will always be true. We just don't use it very much. Okay? I sent you an email, it has your homework in it. Okay? Those of us that are kind of sleeping today, make this the last day that you sleep in here.